Hello students! Last time we learned soil colloid. The characteristics of soil colloid determine that it plays a great role in soil absorption. Soil absorption is one of the important properties of soil, which can preserve the fertilizer applied to the soil and continuously supply the needs of plants. At the same time, it affects the pH value and the buffering capacity of the soil as well as the structure, tillage water, and heat of the soil. Today, we're going to study the evaluation of soil absorption and the evaluation of adjusted soil absorption. Soil absorbency refers to the ability of soil to absorb and maintain molecules, ion suspended particles, gases, and microorganisms in soil solution. Soil can be divided into 5 types according to the different ways of absorbing and maintaining different forms of substances. 1. Mechanical absorption. The mechanical retention of solid particles entering the soil can be preserved in certain soil pores and can be converted into nutrients for plants to use under certain conditions. 2. Physical absorption. The absorption and retention of soil molecular substances is mainly due to the absorption of molecular substances by soil colloid through molecular attraction. 3. Chemical absorption. The process that soluble salts are converted into insoluble salts in the soil and stored in the soil is called chemical fixation. 4. Ion exchange absorption. The cation or anion in the soil solution is exchanged with the cation or anion in the diffusion layer on the surface of soil colloidal particles and then stored in the soil, which is also called physical and chemical absorption. 5. Biological absorption. Soil microorganisms, plant roots, and some small animals can absorb and retain the available nutrients in the soil. This part of nutrients can be returned to the soil through biological residues to become slow-acting nutrients. Among the 5 types, ion exchange and absorption is the most important way of soil fertilizer conservation and supply the process of cation exchange between cations in soil solution and cations in the diffusion layer on the surface of soil colloidal particles is called cation exchange. Soil cation exchange has the following characteristics. 1. Reversible reaction. The absorption process and the desorption process are carried out simultaneously, and the dynamic equilibrium can be reached quickly. 2. Equal charge exchange. Exchange with the equal number of charge moles. 3. Quick response. The exchange function is completed in an instant. 4. Subject to the law of mass action. The cation exchange capacity is affected by 3 aspects. 1. It is the influence of electric charge. The exchange ability of high-charged ions is strong. 2. It is the influence of ion radius. The smaller the radius of ions, the stronger the exchange capacity. 3. It is the influence of ion concentration. Low-charged ions can exchange high-charged ions at high concentrations. Cation exchange capacity refers to the total amount of cations absorbed per unit weight of dried soil under neutral conditions, which reflects the soil's ability to maintain effective nutrients. The greater the cation exchange capacity, the stronger the soil fertility retention. Cations absorbed by soil colloids can be divided into 2 categories. One is base ions including Ca2+ ions, Mg2+ ions, K+ ions, Na+ ions, NH plus ions, and so on. Another group is acidogenic ions, including H plus ions and Al3 plus ions. Generally speaking, base ions are more beneficial to plants and acid ions are harmful to plants. Generally, base saturation is used to express the molar ratios of exchangeable base ions to all exchangeable cations on soil colloid. The site of soil base saturation affects the effectiveness of base ions. The greater the saturation of base ions on colloid, the higher the chance of being exchanged by other ions in solution, and the higher the effectiveness of the base ions. This effect is called ion saturation effect. In production, we often adopt centralized fertilization measures to improve fertilizer efficiency, which is the application embodiment of this effect principle. The main measures to adjust the soil absorption performance are as follows. Apply organic fertilizer, return straw to field, and plant green manure, etc. Improve soil organic matter content. Improve soil texture, and improve soil fertility retention and supply performance. Proper tillage improves soil aeration and water retention. Promotes microbial activities, promotes nutrient transformation, and increases available nutrients. Reasonable irrigation and drainage give full play to fertilizer efficiency and promote nutrient transformation. Increase the concentration of calcium ions by adjusting the pH value of soil. Enhance soil cation exchange performance. Alright, that's the main content of this class. See you!